as I've told you that Thomson was the one who made this effort to explain the structure of atom, but somehow he failed due to few drawbacks, as we have done in Thomson model. So the second attempt was made by Rutherford. So what he did, he gave his model, he gave his model of structure of atom by performing an experiment that is called as Rutherford scattering experiment. So for the experiment, he took an apparatus. So first of all, I want you to know what the apparatus actually is. That is shown in the figure. See, we are going to study that. So he took the lead block. As I have told you that lead is inert. We have done in radioactivity as well that lead is inert. It is used to keep the radioactive material because it is inert towards the radioactive material, and it contained the radioactive material. As you know that radioactive material is that which has the tendency to emit certain kind of radiations, alpha, beta and gamma. Out of those three radiations, alpha radiation was made to pass through this lead sheet. This lead sheet contained a hole in it so as to obtain the fine beam of rays. Then he used the sample he used for his experiment was the gold foil, the thin gold foil, and around it was a fluorescent material screen. See, look, you know what is fluorescent material screen? We have done in a few experiments back also. Fluorescent screen has the ability to glow whenever any particle strikes it. It produces scintillations, the colorful patterns. We did in the previous topic also as well. So, and the most important property of this screen was that this screen was movable. Now, what is the purpose of taking a movable screen? We take this screen as movable so that it can capture the maximum deflections which are occurring when the alpha particle strikes the gold foil. We don't want to, the Rutherford didn't want to miss any of the deflection. That is why he took the screen which is movable so that it can move and capture all those deflections taking place. So he can know what the kind of the deflections it can produce when the alpha particle strikes it. And then this figure is showing the observation when he passed the alpha rays through the gold foil. So on the atomic level, what happened, this figure was showing it. So now we will be doing in detail. See, again we are starting with the topic again. See, the lead block, this is the alpha particle getting emitted, thin foil, these are the deflections which are produced, this is the movable screen which is capturing those deflection. So see what happens. When he passed the rays, he saw the following observations. Few rays pass straight without any deflection. See, you can look in the first figure, these rays are passing straight. Even this is passing straight, this is passing straight, this is passing straight. So maximum of the rays pass straight. The other observation what he observed was that few rays suffered small deflection. You have seen this small deflection, and few rays were encountered the large deflections, and you will be surprised to know that the few rays retrace its path, they turn back, they undergo such a strong deflection, they retrace their path. So it leads to the conclusion after the performing experiment, seeing the observation, this experiment made the Rutherford to conclude following facts, that is, he found that because maximum of the rays pass straight, that means most of the space in atom is empty. I repeat, most of the space in atom is empty. And as he saw the deflection, small and large deflection, that means the alpha particle actually encountered some dense body which leads to the deflection in them. Whether the deflection is small or large, but they hit some dense concentrated mass. Rutherford called that dense concentrated mass as nucleus. And he told that this nucleus might be present in the center because the deflections were very few, and moreover the deflections, like out of, you can say, the 10,000 rays, only the few rays got deflected. That means that mass is concentrated in a small area. So he made the conclusion, I am repeating the second conclusion, listen to it carefully, that according to him, the small dense mass is located in the center, that is called as nucleus. The third observation what he saw, that few rays retrace its path. It was shocking that there was such a strong deflection that the rays retrace its path. It showed that this kind of deflection or repulsion, you can say, can happen only between the charged particles. So this observation lead to the conclusion that the nucleus might be positively charged, because we know alpha particle is positively charged. So when a positively charged particle was approaching the positively charged nucleus, that can be the reason that it got deflected. It suffered such a huge deflection that it retraced its path. So these were the observations and the conclusions, as I've told you. I'm listing it again, just listen it carefully. Observation was, many of the rays pass straight, few were deflected through small and large angle, and few retrace its path. And the conclusion made by the Rutherford is that most of the space is empty in the atom. There is something in the center of atom, a dense concentrated mass located in the center occupying a very small area, and he called that mass as nucleus. And third, nucleus is positively charged, because few rays retrace its path, so it made to the conclusion that nucleus is positively charged. So this whole the observation and the conclusion made the Rutherford that it was possible for him to give a model based on his experiment. So he gave the Rutherford model, that is C. So according to him, that Rutherford model resembles the solar system. According to him, the Rutherford model structure of atom resembles the solar system. Like we know, in solar system, the center contains the sun. So similarly, in case of atom, he said in the center is the nucleus. And as the planets revolve around the sun in a definite path, so he said accordingly the charged particle is revolving around the nucleus in a specific path. So the Rutherford said that the atom consists of two parts, nuclear and extranuclear part. Nuclear part, which is a nucleus, and extranuclear part, which comprises of electrons moving at very high speed. I repeat, he said the electrons, the negatively charged particles, are not stationary. They are revolving at very high speeds. So this is how the Rutherford was able to explain the structure of atom.